Okay, so in this video, I'm just basically gonna show you how you'll tackle questions based on simultaneous problems. Then, let's say maybe you have a system of two equations. Let's say x plus 2y equals. For simplicity, let's just say x plus 2y equals 5, and minus x plus y. This let's just say it's let's just say this is equals to 1. So now, if you want to solve this equations, you can either use the Gauss law of elimination, Gauss-Jordan method, or you can either decide to use Cramer's rule. So it doesn't matter if they specify, then that means that you have to use the method that they prefer. So now, if you're going to use Gauss method of elimination, then you have to write this equation in augmented metric form. So for this one, you just write the coefficients. You have 1 minus 1, and then here you'll have 2 and 1, and since you have an equal sign, you'll denote that and write the constants there, 5, 1. So now this will be your equation in augmented metric form. So now for the Cramer's rule, that's different. Okay, let's start with the Gauss law of elimination. So what we want to do is like we want to obtain zeros here and here diagonally, so since it's a 2 by 2, that way we make this diagonal to be ones. That means like we can then further find the values of x and y. Okay, so let's see. So we want to make this one to be 0. How do we do that? So if we want to make this one to be 0, we can replace row 1 with row 1 minus 2 row 2. So if we do that, then we have 2, let me just do this, we have 2 minus 2 into 1, which that will give us 0. And here we'll have 1 minus 2 into minus 1, so that means we'll have 1 plus 2, which this will give us 3. And then here we have 5 minus 2 into 1. 5 minus 2 into 1, that's going to give us 3. That's going to technically give us 3 since it's 5 minus 2. And now what we want is to make this one to be 0. So we can replace row 2 with row 2 plus row 1. That way we can get 0 here. So we have minus 1 plus 1, that will give us 0. And then we have 1 plus 2, that's going to give us 3, and then we have 1 plus 5, that's going to give us 6. Now what we want is to obtain ones diagonally, so what we can do is like divide row 1 by 3 to get that to be equals to 1, and we can also divide row 2 by 3 to get that to be equals to 1. So what we can do here is we're going to have 1, 0, 1, and then we're going to have 0, 1, 2. 6 divided by 3 is 2. So that way, remember, this is your x, this is your y, and this will be the equal sign in that. So that technically implies that x equals 1, and then y equals 2. That's when you use the Gauss method. But now, if you want to use the Cramer's method, which this one I technically prefer because it's way simpler, unlike using the rows and stuff to manipulate that. So for this one, you find the determinant excluding the constants. So that means you'll have 1 minus 1, 1 minus 1, 2, 1. And then from then you just evaluate the determinant. It's 1 by 1, which is 1, minus 2 by minus 1, which is just minus 2. And then 1 minus into negative 2 is just going to be 1 plus 2, which gives us 3 here. And then you find the determinant excluding the x coefficient. Now this one, be careful. When you exclude the x coefficients here, you'll start on this side. You'll start with 5, 1. And then you'll follow up with the remaining 1. And then it's 2, 1, like that. So now this is the same as 5 times 1, which is 5, minus 2 times 1, which is just 2. And then that's going to give you 3. Then you find the determinant excluding the y coefficients there. And then for the y coefficients, you just start with this one. So it's going to be 1 minus 1. Then you exclude the y's, and then you're going to have 5, 1. You're going to have 5, 1 there. So 1 by 1, which is 1, minus 5 by minus 1, that's going to give you minus 5. And then from then, you're just going to have 1 plus 5, which gives us 6. Now x will be equals to dx over d, and then y is gonna be dy over d, and then that means like x will be equals to dx is 3 and d is 3, y equals dy is 6 and d is 3. Then here you get x equals 1 and you get y equals 2. So that's using Cramer's method to solve for this one, and then this is using the Gauss method. So it's technically simple, really. Like just practice this 2 by 2 system, this 2 equation system, and see if you understand both methods of how you can solve for this one. So it's not that complicated, really.